colleague, who's... Is the mic working? Can you hear me? Okay. If I might just quickly introduce Safra Al-Amri, who's worked with me on various AI projects in the past, currently doing her PhD with the University of Birmingham in the UK, and also finishing off her doctorate of strategic intelligence with the American Military University. Her background for this is related to the Statistics Center in Abu Dhabi, and there's a lot of thinking going on about how we are transitioning from conventional statistics to more of intelligence-based systems, and Safa's the researcher leading that area. So, without further ado, we're going to start with a video, which you may or may not hear. The interesting part to me is that I first joined Greenpeace in 1984. So that's over 4 decades ago. We were going, I think we need to be careful about climate change and the risks. 4 decades later, I'm now starting to hear a few more people talk about it. So the question is, how far can we see ahead? You know, with models, conventionally, we've had a horizon of 5 or 10 years, and maybe if somebody's planning a major structural or infrastructural development, they'll be thinking 25 to 50 years ahead. Most of the housing stock where I grew up was at least 200 years old. So the world we're living in now is needing to be planned for 50 to 100 years minimum. Can you hear?
From sea level rise to storms to extreme heat. Now these are extremely complex systems, and these systems, we're getting into a phase where these impacts are increasing in frequency, they're increasing in severity, and they're becoming more unpredictable. Now, there are multiple benefits to use AI as part of a toolkit to build resilience. Now, that said, there are some practical constraints. So, for example, in a survey of public and private sector leaders, 78% of them said that they don't have the technical capacity to use these tools. 67% said that they don't have confidence in being able to get the data and hence have confidence of the analysis that comes out from this data.
Okay, probably better if I just get on with the talk. So from my perspective, I've been working for the last few years with digital twins and digital twins in healthcare. My background is a senior consultant orthopedic surgeon, and I was fortunate enough over the summer to spend some time with Foster and Partners, which we'll talk about in a minute. So, the problem we're dealing with, we know within the next 25 years we're going to have 70%, more than 2/3 of the world's population are going to be living in cities. We know that the construction sector alone is contributing nearly 40% of the carbon dioxide. Okay, so it dwarfs things like transport. This is a really major issue to us. And consequently, we know that something like 2/3 of buildings are never really designed with this in mind. People can only see the immediate sort of criteria of what is necessary in order to pass the building regulations. And ultimately, it's a profit-based industry, so of course it'll be driven by that. We see the temperatures steadily rising here. I mean, I've seen 54 degrees C in my car. Most people will see it get to a point above 50 at some point. And usually that has an impact on the construction industry because the workers are working outside under duress. You know, it's a very difficult environment for them, and they get a lot of injuries as a result of things like heat stroke as well. So we need to look at how we're going to use these adaptive and AI-driven tools to try and get a better understanding of not just our environment, but also how the environment's acting on the one that we create. Ultimately, the whole of the built environment is about protecting us. You know, that's where hierarchy of need comes in. The research question then is, how can we have an AI-driven, agent-based digital twin system? And digital twins have been around for a few years now. I mean, you all know Rolls-Royce and GE, when you fly from one continent to another, are monitoring the engine probably 30,000 times a second to make sure that it's going to behave. Taking that and applying it to the other parts of robotic environments and built environments, therefore, is almost a natural extension of engineering. But we have to consider with that the ability to then simulate, to use this as the groundwork that you can build on. We can use synthetic augmentation when we don't have the reliable data that we need. And we can use this tied in with forecasting, as you've heard from the other speakers this morning. Therefore, the focus is the AI agents, how they cooperate together, and how we then fuse the real world with this synthetic data to build out the scenarios, and therefore, from that, we can have adaptive modeling and a learning system. Ultimately, we know there's risk, but there's also the uncertainty. The risk we have to mitigate, the uncertainty is harder to predict, and that's why we start to build these models. So longer term, the research aim of something like this is an agent-based digital twin frame. This frame, we can extend it in almost any direction that we wish if we have the relevant data for it. My personal interest is in how we're developing healthcare systems with the resilience and flexibility, having had experience of managing emergency operations centre during the recent pandemic. I'm also very interested in how we're actually going to be building the environment that the generations after us will live in, because they won't thank us for it if we get it wrong. So, moving on from this, just wanted to make sure those of you that are here appreciate what a digital twin is, this virtual replica of the building, that we have multi-agents. These can work and cooperate and simulate just the same as if they were people performing tasks and processes. Basically, if we can describe that process, we can map it, and then we can actually build agent systems that will correspond to it. We also then have this whole issue around the uncertainty modeling, because you get tipping points. We can be aware of risks which are generally linear or maybe exponential, but it's when you get this hyper-exponentiality of combination of risks, which then makes the situation much more uncertain. We reach tipping points, as most of us have seen. We haven't even talked about nitric oxide or methane. We're still talking about carbon dioxide. So these are going to become very major factors. We want to map this out, and in the interest of time, I think I'll just point out that the gap from the background reviewing this is that when we have these digital twins, we need to consider how we're building this climate resilient design into architecture, so that as we move forward, it becomes an integral part of the way we think about the built environment we live in. Our background, as I said, I was lucky enough to spend some time with the Advanced Research Department in Foster & Partners. This is an architectural firm with a couple of thousand people. Massive work. You're about to see the National Museum open next week. They were responsible for the design of centres like Masdar, which is a future-looking city in Abu Dhabi as well. Safa's work with the US intelligence fraternity is very much about how we have the ability to process information and process it in near real time. These principles hold true across any discipline, really. And then the pipeline that we've chosen for this is one which is well established, an automation pipeline for the built environment, which, as you can see, I won't have time to go through this afternoon. But like anything else, it's the principles that matter. So we have, starting with definition, how we brief people. This will go from the one who's paying for the project to the architects, to the engineers, structural engineers, the design concepts, making sure that this is structurally sound. Once you have those technical designs in place, the process usually goes into building information management systems, BIM, and then through to construction and the handover. And then that little one down the end, the actual use, the facilities management. This is the life cycle of the building. So what might take you maybe 18 months and then another 2 or 3 years to get to the point you have a structure, suddenly, all that's done, dusted, forgotten. And the next 100 years is what really matters. Is it an efficient building? Is it doing the job? Is it going to cope with the demands that are going to be made on it in the future? So we have this methodology that we've put together of using a hybrid AI and digital twin framework, building in these pipelines with multi-agent architectures, which we've discussed. Aligning with this intelligence cycle means that once you collect, you process, you analyze, you disseminate. I mean, this is basic engineering in a way of the knowledge. And then we have to stress test it in order to validate it and provide it as decision support. Most of you will know at least some of these tools. I was very fortunate once to have some training from the Meteorological Office as a pilot in the UK, and got an appreciation for some of the in-depth modelling. It was also one of the major centres, obviously, for high-performance computing. And from that, we've managed to get data sets going out to 2100, so 75 years from now, which will predict down to the area of the Abu Dhabi or Dubai as to what the microclimate is likely to be like over that period of time. So we can predict the degree of temperature change, the humidity change, the likely wind patterns, etc. These complex models are meaningless unless they're integrated with the actual built environment we're planning, and therefore you have to include the GIS, the footprint of the building, if you like. And then on top of that, we have to consider the fact that you're fusing synthetic data until we get enough accurate real data to replace it, to substitute it for the real thing, so to speak. I only put this one in as an indication. There's actually 8 layers of rather complex protocols. This is the data layer, and the reason I mention it is because there's 2 really key messages. One is that the data needs to be curated. Somebody needs to be legally responsible for that data. And they might have to be paid for the upkeep and maintenance of it. And we should look towards open data as much as possible to help the development of these systems. The other is that there needs to be a governance process, which is a federated governance process, so it meets the appropriate standards. Coming to this agent cycle, once we have our representation of that environment, then we want to ensure that it has teeth, basically. It's got an environmental simulation attached to it, that we can build structurally on that, and we can then optimize it for the local structure. We want to consider the cost of the materials. One of the project's aims longer term, developing the concept of observatories, is that we should get a clear indication for the likely costs of materials in the future, because we need to consider, that we're still in a capitalist system, and therefore a building has to pay for itself. That's going to be the motivation for change. From that, we get the forecasting and then the insight. So, we expect to have enhanced climate adaptation on a local scale. We want to have optimized resource efficiency, and we want to have this as a repeating cycle. Basically, like the washing machine, it goes round and round and it learns each time. We talk about MAPE-K. We monitor, we analyze, we plan, we execute, and there's that core knowledge base for any sensor, any part of the system. So, to give you an idea, I'm sure all of you have seen these kind of sort of structural mappings of places, but it allows you to set things in context. I'm sure many of you have heard now the fundamental problem we have with AI at the moment is setting its context. So to me, you have to consider the protocol for the human, you have to consider the business protocol, the machine learning protocol, the data protocol, the governance protocol. All these have to be able to talk to each other. And that's why agentic or autonomous agentic architectures are very important, because they can do a huge amount of computing in the background. Here now we've transitioned across to a digital twin, and you can see how these agents are basically, the process is set off. It's a bit like sort of one of those bobsleigh runs as they sort of go down the hill. They sort of give it a push, and then it just goes under its own weight. And what we can see from this one is it's generating some output suggesting that in that environment over a period of time you're going to see an anticipated rise in temperature, that it's going to have this likely cost, that it's going to require these sorts of materials. This is the, if you like, the price you have to pay for doing it. We obviously have other components to the system that we're working up at the moment to evaluate different recommendations, but the key, as I say, is that agentic architecture. Now, everything comes with a price. One of the big problems that I'm very interested in is AI models can drift. If you start giving them new data, new information, they learn, but they might be learning the wrong thing. Most people sort of laugh at the idea that somebody taught a large language model without appropriate guardrails, and then it goes off and misbehaves. Well, that's okay, if it's just going to slightly upset somebody. It's very different if it's going to miscalculate something and not provide adequate, beams to provide the load bearing on a building. So we need to make sure that this actually has ways of detecting its own drift and then checking. So it's basically self-monitoring in that sense. There can also be gaps when you have to recalibrate. And one of the keys to this is that you can build as many sandboxes as you like, and you can go out and test as many different permutations as you like until you find the best options, the ones that are most relevant. Of course, we want to protect the privacy. So, in real terms, where have we got so far? Well, we know there's gaps in the data. There always will be when you're dealing with a combination of government and private sector, because people, they'd love to share information, but they're probably under some kind of clause that says they're not allowed to. So the question is, how do we compensate for that? How much more of the time are we using synthetic data? And in some of this, we're probably using around 70% approximate values, and we're getting about 70% accuracy. Obviously, we need to improve on that sort of thing. But it is an early stage prototype. It's more, as I say, a framework that you can just plug anything else into. And therefore, those interoperability restraints will depend a little bit on the companies and commercial interests involved, and also the commercial load. From the recommendation side of this, obviously, we're very happy to collaborate with people and develop partnerships around this. We see that it's Big Five, I think, this week in Dubai, the main construction conference of the year. The 5 dimensions of construction, basically is X, Y, Z, time and cost. So, anything that needs to be developed has to be realistic about those constraints that are going to be imposed on any future work. But I think that enhancing the validation of these pipelines builds the credibility and improves the standards alignment. Okay, I think I'll leave it there. Thanks.
Okay, thank you, Simon. Any question from audience?
Yeah.
I can start with question first. Simon, you're talking about a lot about the synthetic data, but actually how are you creating the synthetic data?
Sorry?
How did you creating those synthetic data?
In fact, ironically, it's often easier to get open sources of synthetic data than it is to get the real data. That's out there. And of course, people who've already built repositories of synthetic data want you to use it because they want you to refine it. So, to some extent, it's all about building a virtuous cycle. At the moment, the ones we have used third-party synthetic data because it's part of that sort of federated governance. They are responsible for trying to maintain and optimize. Okay.
I think there's a question from audience.
Thank you.
Hi, good afternoon, and thank you so much for a wonderful presentation. I just have a question that might be a bit general. In general, some industries, even though we present many evidence and data that AI can make our life better in many sectors and it can make things much easier, but we still have and face some resistance. I would like to know your perspective about how to deal with this resistance and this challenge that many people still, with all the evidence, they are still reluctant to use the AI tools that are available in this time and age.
I'd have to say I found it quite hard to understand. Can you repeat that part?
Yeah, can you say the question again?
What is your perception about when you present an idea or when we want to use AI? sometimes we face challenges from the decision makers that there is they are not sure about if they want to use AI or no. There are always a challenging of convincing the management that it is reliable.
Firstly, I expect I'm being recorded, so that I can say some various things when I'm not on record. I think everybody wants AI to be the savior for many different problems that we face globally at the moment. I would argue that a shot across the bows to us was the impact of social media, where having something as simple as a thumbs up and thumbs down has done more to polarize society and cause trouble in the last decade than almost anything else. Why? Because ostensibly it was misprogrammed. As we know, it was driven to drive traffic to their sites, to provoke polarization. Not clever. So AI can be smart, but not clever, and certainly not wise sometimes. On the other hand, I think it's very important to see the impact that AI is having globally on societies, because there is no getting away from the fact. I mean, I got a patent back in 2012, so I consider that was my real entry into AI, although I was doing work on ontologies back in 2004 with one of the universities. So, been around it long enough now to believe that AI is most definitely here to stay and to be refined to the level that it is useful. I also come from a clinical background where, as a surgeon, you never have 100% of the information you want to make a decision. If you've got 80% of the critical information, you're probably going to have to make a decision anyway. So the key is hopefully being smart enough to learn as you go along, and from when something's not quite right, don't go into denial, don't stick your head in the sand and pretend it was what you wanted it to be, but actually deal with the problem. And I think, this is more a test of humanity than it is a test of AI at the moment, because the way we approach this, I usually refer to it as augmented intelligence, because we're at that phase. It hasn't yet got to the stage of replacing people, really. And in some jobs, it's going to be very hard. I know what I was doing for 3 or 4 decades. Yes, you can use robots in certain areas, but the degree of versatility that's required, it's still got a way to go. So when I see something like this, to some extent, the human intelligence and the human, on the loop, if you like, rather than in the loop when the agents are doing their work, is a really key part of this, to say, if I ask too much of it, it will probably fail me. If, however, I've already got a very well worked out structure, I can't take the credit for that. A lot of very smart architects worked out the entire system end to end. And we take apart that structure and we break down, the project into the objectives, into the goals, into the tasks. We're getting to the level of defined small units that an AI can not just manage, but can actually be evaluated on its performance for managing. So my actual work with University of Birmingham in the UK is more around the governance of agentic architectures, because that's the bit that what I'm actually doing, I'm cheating. I mean, I'm sure any of you who's in an academic career understands that the best way to get a good idea is to sort of steal it from somewhere. So in medicine, we have well-established governance processes. Why? Because people don't trust surgeons. They might sort of get it wrong, or somebody said earlier on, screw up. So if you don't trust people, what do? We have safety mechanisms in place to make sure they can't get it wrong. Or, if they start going off the rails, you get them back on the rails, okay? Brilliant. Well, why don't we do the same with the agents? So all I'm doing is I'm taking ostensibly the processes that we use to manage people in everyday life, in professions, and applying those processes to the agents, so the agents want to behave well. If an agent doesn't know how to behave, I don't know, some of you have probably got children around here, but you can't really blame a 3-year-old when they do something wrong, because they haven't got the full context, life experience to go, maybe I shouldn't have done that. You know, they're on that learning curve. If you've got an 18-year-old, you probably can blame them, because they've been around long enough. And it's the same sort of thing when we're building these agentic populations, that, they don't have that contextual setting that they need in order to appreciate this. So, I'm doing things like building in the Ikigai principles, sort of what's good for the agent, what's good for the environment they're in, is it useful? And if they fail, the beautiful thing about agents is you can switch them off. Sorry about that. Okay, but you know what I mean. So hopefully that was a roundabout way of answering the question. Anybody else?
Any other questions? If not, we'll thank Simon again.
Thank you.
So we continue with second talk. So second talk is from Liu Pen Hong. Yeah. It's from SC College in Cornell University. Yeah. Is that you have the same titles, talk title? So
yes, data-driven insight into managerial ability.
Yeah. Okay. So it's a data-driven insight into managerial efficiency, hospitality, and sustainability. COVID-19 shocking resilience, and hotel asset valuation. Pretty long titles. Okay, so you have a short title. It's building a climate resilient and sustainable future.
So that's the conference title.
Okay.
Yeah. Thanks. Professor, should I start?
Yeah, sure.
All right. All right. Good afternoon, everyone. So my research is today I will be talking about so in the capital and energy-intensive sectors such as hospitality and real estate, managers directly control the conversion efficiency of labor, energy, and maintenance resources into service outputs. So yet existing measures of material quality rely largely on demographic or event-based like data, such as like for example, level of education or like return on asset. Now, although those data can be limitedly available, they are not really like the best or most effective way of calibrating managerial efficiency. And so with my research, essentially what I'm trying to answer is, are more capable managers creating value by producing more, wasting less, or identifying opportunities? And so my way of identifying opportunities will be calibrated in two ways. The first one is how resilient is the specific hotel under management against, like, for example, the COVID shock. And also, in the case when the hotel needs to be sold, whether it can be sold with a premium or not. So for our efficiency score, we follow the paper from Demirjian et al. In 2012. And it essentially is a non-parametric optimization procedure of estimating production frontiers. So essentially what we're trying to show is whether high ability managers are truly operating more efficiently, and whether that same mechanism that drives higher profits and property values should reduce energy use and environmental intensity. And so the core of this efficiency score is it resembles the like the output over input, but then we allow some range of maximization, which sort of tries to calibrate the strategic movement of managers. So we give them room to, sort of speaking, wiggle around, to play around with different weights into input. And if in the case of selecting output, what weight should they assemble to each output? So we give them that room to sort of like to play around with. And a simplified representation will be, in the case, a graph such as this. Again, so this resembles a frontier analysis with all the x's on the red line on the frontier to be the most efficient ones, and all the other scattered dots out there to be inefficient. And essentially the geometric distance to the frontier will be their relative efficiency score. So if you're on the red line, then you are getting an efficiency score of 1. We normalize that to 1. That means like you're operating at the most efficient level allowed within this sector. Now, if you are further away from the red line, then you will get a lower efficiency score. So that is how we get the first stage, we get the efficiency score. And so our output is defined as revenue per available room. You can think of this as for every hotel room per day, how much revenue you are generating. And our input is very standard hospitality cost inputs such as labor, marketing, and then also like utility bills. And so for those input sectors, we want to study like how efficient managers are utilizing them to generate, in our case, the only output, revenue per available room. So our second step is to use the found managerial ability and then to regress it against some macroeconomic conditions and like hotel characteristics. And after we remove that, the remaining epsilon, for many of you there, this is error, but then for us, it's really like the residual efficiency that cannot be explained by external factors. We assign that to the managerial ability. So essentially what we're saying is we define managerial ability as the non-explainable efficiency that is like, that cannot be explained by like other external factors. So essentially we're using a residual form to estimate our managerial ability, which is our key variable of interest. And so our data come from the Coldwell Banker, Richard and Ellis CBRE, which is one of the largest like hospitality data provider. And it comprises of 4,600 hotels across 40 largest hotel markets in the United States. And since we have monthly data into hotel years, we have almost 40,000 observations. And so we have the top line, bottom line operational performance information, and which is why like it allows us to do the analysis, especially into the input analysis. And I would like to show some summary statistics. And with the summary statistics, you can pay attention to the managerial ability score. So essentially, one of the first validation check is we want to make sure the mean is at 0 because we're using a residual analysis. It's essentially the unexplained term. It should be centered at 0. And also, again, for the environmental part, we are using the utility spending per available room against a per day data. So as you can see, the scale is not very big. It's really just $5 per room per day. And again, so although I will show you later that so manageriality will bring you like significant changes to the utility bill. But then if you are speaking on a scale like dollar to dollar effect, this will sound insignificant, which is why we want to motivate it with real estate price appraisal. So the first framework of our research follows the impact through measurability. There will be operational efficiency. And with that, there will come with environmental outcomes. And after some normalization, so we found that one standard deviation increase in measurability reduces the utility bill by 15 cents per available room. So if we're talking about like a 200-room hotel, this will be about $10,000 US reduction in utility bill itself. So this is, again, so this may seem like insignificant for investors too, which is why we'll also show some further, like let's say, motivation for them to recruit managers to increase manageriality, thereby reduce the like environmental impact. So next, I would like to show you the resilience through COVID. So as the data will speak for itself. So the green line is the pre-COVID profit per available room again, and with its reaction to manageriality. So what we know is, so with COVID, there is a parallel shift towards like a parallel downward shift. And so our explanation is in the US market, because our data is from the US. So in the US market, managerial ability still rewards hotel with the same efficiency, with the same profit-generating efficiency as it was pre-COVID. And so therefore, like manageriality is providing, sort of speaking, like a protection against like COVID shocks. And so to validate our research data, so we typically selected 2020 as our shock year, because that was like the year where COVID hit hardest, and there was the most uncertainty within the market, and we also we can justify that with like stock market shocks. As you may know, in 2020 in March, NASDAQ saw its like largest crash, which is like the reason why we selected 2020 as a benchmark. And then so here, I mean so again, like hotel managers still may say, okay, this is not enough for me to justify hiring managerial, like able managers to do the job. So we're like, okay, fine. Then maybe we should aggregate that even more. So we want to study into the real estate market. So when a hotel tries to sell itself on the market, how much does managerial ability reward that? Which brings us to I believe, the third part of my research. Again, so the framework is such that manageriality will affect sales price and appraisal value through some moderator effects, such as hotel size, building age, and the revenue mix. So hotel size really just means how many rooms there are in that hotel. And the building age is like how old that hotel is. And the revenue mix is how complex is like hotel. Like for example, you will say a resort with like theme parks and like restaurants will be more will be harder to manage than like an eco hotel where there's just rooms and there's like zero service. And so our result shows that no matter, it's like irrespective of different ways of choosing your managerial ability, whether you want to use the previous year's managerial ability to study its effect on real estate price, or you want to use the previous 3 years managerial ability, or it's like 5 years, or like the latest available managerial ability score to study the real estate price. So what we get is for 1 standard deviation of managerial ability increase, your sales price for your property will go up by around 20%, like 20 to 23%. So to put that into like a numerical scale, an average US hotel per room is around 200,000 US dollars. So if we're talking about like a mid-size hotel of like let's say 150 rooms, that will be around that will be around 33 million. So again, 20% of 33 million, that will be like around almost 7 million US dollars, just with 1 standard deviation increase in measurability. So essentially, our mindset is, you know what, we'll just motivate hotel investors by saying, look, get good managers so you can sell your hotel property with a higher price, and the environmental impact will come as a byproduct. So that is like essentially our mindset. Because otherwise, we're all human beings, and because of that scale effect, it'll be very hard to motivate managers to do good things for the environment. Again, last but not least, this is just for like some robustness checks. So we'll also study the moderating effect, and we were able to show that so like the hotel age and the revenue mix, and so the hotel rooms all show some moderating effect. So what this really says is older hotels, like hotels that are operating older buildings, like vintage hotels or boutique hotels, and large hotels, or any like big hotels, very diverse hotels such as the Atlantis. It has a theme park, very good restaurants, like a very diverse revenue mix. Those kind of hotels will be requiring more able managers. Again, Emirates Airline took a very different approach. For them, they reduced cost by just focusing on 2 types of like airplane models, just the Boeing A380 and the Airbus A380 and the Boeing 777. But then, so in their case, okay, don't take this for granted, but then in their case, they might need less able managers, so they don't have to pay a premium for more able managers. Rather than, they probably want to relocate more able aviation managers to fly Dubai, which they will fly like a more diverse airplane, thereby, according to our research, if the model applies, then they are the ones who actually need more able managers. And how many minutes do I have?
Yeah, I think so, any question from audience?
Oh, okay.
Okay, probably I'll start with some questions. So you're talking about you have the data from 2010 to 2024,
yeah,
which COVID happened in 2019, right?
Yeah.
So the data pattern actually has a big change during that year, right? Because you have a normal time, which is 2010 to 2019. Yeah. That's just normal time. Then COVID happened. Then suddenly the whole pattern, the data pattern changes.
Yeah.
So how did you model that changes? Do you have pay special weights on the data during the COVID? So the model.
So well, we saw like a huge change in trend where it only happened in 2020 and 2021.
Yeah. Okay.
Yeah.
So because that lockdown starting in 2020, right?
Yeah, and it was largely because of like uncertainty, like policy uncertainty.
Yeah.
And then again, the second part of our research, what we found was really just a parallel shift in operating profit. So essentially, like everyone just got, sort of speaking, everyone just got like hit in the same way. And then we did not record, like we did not do any specific adjustments to our data because we saw the pattern.
Okay. But let's assuming that in the future there will be another second COVID. So is that the hotel was better prepared if using your model to do some modeling if that second COVID is hit again? Is that possible to do that?
What I mean, like from what our research shows, so more able managers are able to report a positive operating profit in a shock. So I guess if there is one takeaway lesson, that is, we know, let's say in 5 years' time, there might be another wave of shock.
Yeah.
And probably the best thing to do is like start getting your 4-year, 5-year contract and attract the most able managers.
Okay. Okay, thank you. Any more questions from audience? Yeah.
Oh,
Hello.
yeah. Sorry.
Okay. Thank you for your informative presentation. I just have one question. You've mentioned that at 2020 you have picked your data because the pandemic was at its highest, right?
The uncertainty.
Yeah, and due to the uncertainties, how did you get over the uncertainties at your research to make sure that the data that you are providing is at maximum accurate numbers?
So that uncertainty is not. So that's a very good question. Thank you. So the uncertainty is not. So it's like a consumer spending uncertainty. Is it because people are uncertain, they don't want to spend? So that will directly show into the shift of our operating profit. But from our data perspective, that is not a huge problem because our data is hotel by hotel. It's not consumer by consumer. So as long as that hotel is still reporting data to us, our data's uncertainty or our data's variation doesn't change that much. But then from a hotel's perspective, they will see a huge, like a larger fluctuation in their earning. So that I think that's the different understanding of uncertainty, depending on your perspective. If you're a hotel manager, then your uncertainty is really just a variation in your earning. But for us, as long as you're reporting data to us, our validity is not that much affected, unless it becomes like large outliers.
Okay, thank you. Any more questions?
Hi, thank you so much for the presentation. I mean, I know that many people see that life before COVID is different than life after COVID. And you mentioned that the hotels that have major facilities and many things suffered more. What about the boutique hotels that, for example, they have only how many rooms only and very limited services?
Yeah, so boutique hotel is, I mean, like, they are considered like an extremum. So in their case, if they're like the very new ones, like newly built ones, like a lot of them pretty much just went on resale, like they're just gone. Now for the ones, so from our data, what we saw is from the ones that are 125 years and older, those are the ones that saw the largest discrepancy in manageriability. So with good managers, they are able to survive and they're probably able to prosper. But then with the ones that are having bad managers, the only chance is just to sell it to chains. Like usually, like, again, this is like really just an experience thing. It's not factually tested because we don't have that data. So what we saw is independent hotels usually have worse managing scale compared to chain hotels. And those boutique hotels were usually family and private owned. They were sold to chains. That's what we saw. Again, but then this is this is not like research tested. This was not like proofread.
Yeah,
But then
understood.
this is just between
Yeah.
between us.
Understood. Thank you so much. Thank you.
Thank you.
Okay, thank you, Perhong. Thank you for your talk. Right, thank you. Our final talk is from Professor Chozo, Department of Environment Science, University of South Africa. The talk title is The Climate Change Adaptability and Mitigation Efforts at the Airport Company in South Africa.
Good afternoon. Thank you so much. My name is Patricia Zomundaramo. I work for Airports Company South Africa, and I'm here as a student from the University of South Africa, presenting climate change adaptation and mitigation at Airports Company South Africa, and artificial intelligence-enabled pathway forward. So I just want to start with the introduction of what exactly is the challenges that we're facing at Airports Company South Africa. We know that climate change poses significant challenges to infrastructure worldwide. So this is the same for Airports Company South Africa, which is vulnerable to extreme weather events, rising temperatures, and resource scarcity. So the company that I work for, Airports Company South Africa, manages 9 major airports across South Africa, which are critical for economic getaway and also visual components of transportation network. So this study just reviews the decade of Airports Company South Africa's climate journey from 2014 to 2024, examining both mitigation and adaptation strategies implemented across the AXA network. So in terms of artificial intelligence, we know that it is an enabler that can be able to help us deal with climate change, and it has emerged through optimized energy management and predictive analytics and automated decision-making systems. So this study basically just explores how artificial intelligence and machine learning can accelerate Airports Company South Africa's progress and address identification gaps in terms of the adaptation planning within the company. So we know that artificial technology transforms climatic data into actionable insights, enabling proactive rather than reactive approaches for both mitigation and adaptation. So this study is aligned to Sustainable Development Goals, Goal 7, which is affordable and clean energy, Sustainable Development Goal 9, which is industry, innovation and infrastructure, Sustainable Development Goal 11, which is sustainable city and communities, and also importantly, Sustainable Development 13, which talks about climate action. So the methodology, I've already explained that we are looking at just the AXA's annual reports from 2014 to 2024. We also looked at academic literature to check the climate change impacts in aviation, and also some global airport technology implementations in terms of artificial intelligence and machine learning. So this analysis followed a qualitative approach where we looked at consumption trends of carbon, water, and energy. We also looked at quantitative methods that we employed, which are thematic analysis of climatic strategy. We also did a technological assessment just to check how artificial intelligence and machine learning can help us to advance AXA in terms of its climate change mitigation and adaptation strategy. So what we have seen is that in terms of mitigation efforts and achievements, the company reduced electricity consumption by 38.3% from 2016 to 2024, which is an achievement from their annual reports. It also reduced water consumption by 22.6% from 2016 to 2024, which is also a slight achievement in terms of their mitigation efforts. And then on the dark side, they had an increase in waste management or waste generation, where we see this as a significant weakness, where they have increased their waste generation by 128.4 from 2016 to 2024. So some other mitigation efforts that are achievements is through their carbon management, which is an airport carbon accreditation program. In 2018, 4 of the airports out of the 9 were accredited at level 1, which is mapping. In 2024, 7 of them were accredited, 6 at level 1 and 1 at level 3. And their aim is to get all 9 airports accredited at level 3, which is optimization, by 2031. So this is just a systematics just to show which airports are accredited at what level. We can see now in 2024 that we have OR Tambo, Cape Town, King Shaka, Port Elizabeth and George accredited at level 2, and then King Shaka, which is notable, accredited at level 3, and we still have 3 airports that still needs to be accredited in terms of carbon accreditation, and they are aiming on getting all the airports carbon accredited by 2031. So this is their target. So what are the potential artificial intelligence application across AXA airports that we have come up with a solution? The first one is HVAC efficiencies. So we have said that the solution is to have deep learning algorithms that can optimize HVAC's operation across AXA facility by enabling real-time system adjustment, predictive maintenance, and automated climate control to improve energy efficiency and passenger comfort. So this is an area in which they can improve their mitigation effort. Another area which they can improve in terms of which AI can help is water conservation. AI-powered leak detection and predictive maintenance system can enhance the effectiveness of managing AXA's water infrastructure, while smart irrigation technology can optimize landscape water use across the airport. So this is some of the initiatives they can employ in order to improve their water conservation at the airport. In terms of waste management, as I've already mentioned, that there's a gap in terms of their efficient management of waste. We have said that there are AL-powered smart sorting systems that they can employ, which automatically identifies and separates waste stream, provide real guidance for proper disposal, and generate predictive analytics to support circular economic initiatives across the airport. In terms of carbon management, they can track the scope 1, 2, and 3 emission data from AXA's business function into unified dashboards, reducing manual data collection and ensuring consistency and accurate carbon reporting. And some other AL is also smart lighting, where machine learning can analyze the usage of light across various areas within an airport to optimize lighting schedule and reduce energy consumption. Ground power units as well, predictive maintenance. I've already mentioned that early detection of leakages and inefficiencies can be optimized through machine learning that can improve reliability and extend the asset lifestyle and reduce resource waste. They can also optimize their sustainable reporting by ensuring that they can use artificial intelligence by automating data collection and integrating information into dashboard and providing predictable insights to support accurate, transparent, and proactive environmental management in terms of sustainable reporting. So another gap that we have come up with or we have noticed is in terms of adaptation, there is no strong adaptation effort in their climate strategy. They are missing climate risk assessment, so there's insufficient systematic vulnerability assessment for airport infrastructure. There's also insufficient integration of climate resilience into infrastructure development. There's also insufficient early warning system and response protocol for climate disruption. And also another gap is that there's absence of comprehensive long-term adaptation planning aligned with the best practice. So what they can do in terms of adaptation, which is AI and machine learning enhanced, is that they can have AI-powered climate adaptation framework. They can have machine learning based climate risk assessment, and also digital twin as well for infrastructure resilience to create digital twins for critical infrastructure just to simulate the climate impacts and test resilient measure and optimize maintenance schedule for climate proofing investment. So what are the key findings? There is strength in terms of their mitigation leadership. We've seen electricity reduction and water reduction, although this can be improved by AI. There's also strong carbon management success, as we saw that King Shaka is already at level 3 accreditation, and there are 6 airports at level 1 accreditation, which means that they are also demonstrating that they want to be in par with international standards and compliance. And also there is measurable progress in terms of them tracking this data. But then the weaknesses comes with the adaptation planning, where they don't have any climate risk assessment and infrastructure resilience strategies. They also, in terms of waste management, are increasing their generation, so it needs upgrades and also intervention as well as circular economy approach. And also their early warning systems are not up to par, and they also need to have long-term roadmap in order to adapt to climate change based on best practices. So the conclusion is that we have a strong mitigation foundation, we have identified adaptation gaps, we need artificial intelligence and machine learning to transform airports company South Africa, and we need a balanced approach between mitigation and adaptation through artificial intelligence-enabled frameworks in order for the company to move forward in terms of climate action. So this vision is for African aviation leadership. In order for airports company South Africa to be a leader, they need to make sure that they integrate artificial intelligence and machine learning within their climatic strategy. That is all from me. Thank you.
Okay. Thank you for the interesting talk. Any question from audience? Right, okay. I have a technical question to ask. You're talking about AI, talking about machine learning, talking about deep learning. Can you have some technical detail? What kind of model you use? What kind of AI model you're using?
So we're not using any AI model as yet. We are just proposing solutions that the airports company South Africa can use in order to improve their climate change mitigation and adaptation efforts, just by looking at their strategy and what they have indicated in their integrated annual reports. So we have not yet simulated any data yet. We're just proposing to the company for them to start looking at that.
Okay, thank you. Yeah, that's a question.
Thank you for your wonderful presentation. So a very quick question, maybe it's sort of like a clarification question. So what is the, like, sort of speaking, cutoff for the level 2 and the level 3? I believe level 3 is operational improvement. And so is there like a specific cutoff, like what variable are you looking at to decide there's a shift from level 1 to 2 to 3?
So in terms of carbon accreditation, it's up to level 5 plus. So level 1 is mapping, where they map their carbon accreditation effort for the company, and then level 2 is optimization. Level 2 is I forgot now, and then level 3 is optimization. So, and then level 4 is reduction. Level 2 is reduction, level 4 is optimization. So just to answer your question, it's up to level 5 plus where the company can be able to reduce their carbon emission in terms of carbon accreditation program. But now only one airport is at level 3, so they still have a long way to go in order for them to reach level 5 plus, which is 4 levels up.
Yeah, thank you.
Okay.
Thank you. That's one more question.
Thank you so much for this wonderful topic and speech. The presentation was good. I just wanted to ask that you were talking about AI and predicting the future. So how would your model or the model that you would create predict the nonlinear behavior that is present in the market, and how much can we trust these models? I mean, there might be some percentage of R-square and mean root square values, and we know that the data, they are not usually linear. I mean, it's completely non-linear, and it's very difficult for AIs to predict the non-linear behaviors until and unless you do use deep neural networks and you put some layers and what activation functions would be used. So my question is, the AI models that you would work or you would create, I mean, how much accurate would they be, and how much do we trust them?
I think this is a very interesting question. As you've already mentioned, that it's very difficult to get AI data as well that is accurate. So I think that already in South Africa, we have infrastructural problems, and we also have a lot of gaps in terms of climate strategy. So for us to get to the AI-driven model, it would take a lot of collecting the data. The data that we currently have is sufficient enough for us to have a picture of what is happening at Airports Company South Africa. But in order for us to run models, we will need to collect more data, which is going to be a challenge for the company as well. So there's no one solution that I can give you right now to say which data model can we run, because we still need to go and collect the data, which is also going to be a challenge as well from our side.
Okay, I think it's time for the coffee break. Let's close this session. Okay, thank you for the speaker.
Mr. Caetano, next one is here. I'll just open this. Time, what time we start? Yeah. The one we received, I don't know, like a team gave me, I copied them one by one, you know, like this.
Oh, I see. I saw a typo there. You see headlines there.
Because, yeah. Last time also you did some for COVID base here, IMC.
I did the cloud based.
No, COVID base?
Yes, yeah.
IMC, I
It
remember,
was
yeah.
COVID based.
Yeah. No, I mean to come our IMC conference.
Yes. When is next year? And why is it refusing? Sorry? No. They just a few issues that were not reading well. Otherwise, I think we're good to go. Oh, okay.